Yo, what's going on, guys? Hope you've been well. I've been very, very busy, and also sorry if I sound very, very tired. And I'm also recovering from cold. So yeah, and I moved. So yeah, a lot of things has been happening. But yeah, all right. So today, I'm going to derive, as promised, the nth term formula for an arithmetic sequence. Last time I derived the nth term formula for a geometric sequence. Usually this topic is taught first and then the geometric, but yeah, watch that other video. So hopefully I don't have to explain a lot of things because it's gonna be very similar to that one. Okay, so all right, so an arithmetic sequence is just another kind of sequence, a special sequence where um, each term or the succeeding term differs from the previous by a constant. Okay, so uh, well, adding a constant. So like, for example, if I gave you something like this, 2, 4, 6, 8, 10, 12. What the heck kind of two is that? Okay, 12, 14, 16, dot, dot, dot. All right, so this would be an arithmetic sequence. The starting number is 2, right? And here you can tell that you're counting by twos. Okay, so then here there's a change of +2, right? +2. So uh this constant, right? This they call this the common difference, and it's usually notated by D. Okay. You could also apply this to subtraction, right? And like, so for example, let me start with -5, and then let's subtract 3 each time. So it's -8, -11, -14, -17. Yikes. Okay, -17, -20, and so forth. Okay. So this would also be arithmetic, right? And uh, the common difference would be -3, right? And I've said this many times to my kids in real life, or my students, that subtraction is addition, right? But with the additive inverse. So you could think of this as adding, right? -3 is the same as saying plus -3. Okay, so yeah. Okay, all right, great. Also want to say, you should also think about it like this, where the minus kind of signifies a change in the smaller direction. So like the numbers are decreasing here. Okay, okay, cool. So hopefully this is enough motivation. So now, once again, let's do this with a general case. All right, so the arithmetic sequence starts with a starting number, right? Typically called a sub 1. This represents the first term in your sequence, your list, okay? Your ordered list, all right? Then to get the next guy, by definition, we said that we have to add some kind of constant to this, right? So here we're gonna add D to this. So then if I'm adding D to this, right, as plus D, then that means that this thing would be a sub 1 plus D. Okay, so the second term would be a sub 2. This is a sub 2, right? And this is its value, all right? And then you do it again, right? You add D to this, you add D to this again. So then that's going to be a sub 1 plus D plus D. But, you know, combining like terms, this thing, you can combine these D's to get a sub 1 plus 2D. A sub 1 plus 2D, okay? And that's the third term, a sub 3. And then one more time, you add D again, and then you're going to get a sub 1 plus 3D for the fourth term, a sub 4, okay? And so forth. Okay, so the goal is to get this, right, for the nth term, where n could be any so just a natural number, right? So starting from 1 and beyond above. Okay, so weird Buzz Lightyear reference that I just messed up, but yeah, you get the idea. Okay, so here look for pattern once again. Okay, so check out the geometric sequence video, but here you see if there's a connection between the position, right, like the nth position and the value in that position. So like, for example, if you look here, geez, let me call this a sub 1 here. That is a sub 1. It's the first term. there's 0 D's that you're adding to this, right? Because this is the same as saying plus 0 D, okay? All right, a sub 2, notice that there is, to get a sub 2, you're adding 1D to a sub 1, okay? And then a sub 3, you're adding 2Ds to a sub 2, okay? So so if you're looking down the list and you're picking it for an arbitrary the nth term, okay, here, this thing, the number of D's that you're adding to the first term would be 1 less than this. So that would be n minus 1, right? So you're plus, right, the D here, and then how many of these D's, this is kind of like the coefficient, right? N minus 1 right here, this, okay? So this is it, okay? This here, okay? So here, it's saying that the nth term's value is just the first term plus n minus 1 times d. Okay. Okay, and like I said in the other video, you could you're given questions like, well, find the 99th term of this, the 80th term of this, the 1000th term of this, and to do this, you just plug into this formula, and they'll typically give you this value. Okay, they'll give you this value and the common difference, right, and the nth, and you just plug in. Okay, you could also have other variations of this where they give you the other variables, and then you have to solve for one of these, and then that just becomes an algebra exercise. I will post examples of that. Okay, expect at least 3 videos from me by the end of next week. Okay, because I feel like I need to be here more often, but I'm just too chicken. But and also just, yeah, I think it's just too chicken, just overthinking things. But yeah, if I get used to this, then I think it'll be very, very good for me and all my students. So yeah. All right, guys. I am very, very tired. Hopefully this helped. And if any questions, like always, message me. And yeah, take care.